we discuss is about IPv4 and how this 32-bit is become 4 octets, how it is separated by dot, total range of IP address. Then we discuss about classes and ranges, and what IP address we cannot use it, and what IP address we can't assign. We can't assign. So we'll see MCPA directly to game U network connections. Just for example, I will try to show the last part. Okay. So what I'm trying to do is manually I'm trying to assign an IP address. Okay. If you want to assign IP address manually, second option, use following IP address. I try to give IP address 0 dot. See, it is throwing immediately an error. 0 is not a valid entry. Please specify the value between 1 and 223. Between 1 and 223, class A to class C ending only. Not a class D or E also. 224 is not there, and other 240 that kind of also not there here, right? See it is. Again, I try to give IP address again 127. He said 1 to 223, but 127 is also not a valid one. Okay, which we cannot able to assign. Maybe I will try 224. Again, 224 is not valid. 240 not valid. Means these IP addresses we can't assign. Class D range, class E range, and 0 series, 127 series we can't assign to our adapters. Okay. And other than that one, remaining we can use it. And we are using only from class A, class B, and class C only, because there are unicast, and that too 0 series, 127 series. Of course, one more series is there, that is separate level there. Okay, next. So when I start with the IP address part, so I told about different things, right? What it is, batch 12, batch 11, okay, floor numbers information. It means you're dividing like identification purpose. You follow one part is common for everyone. Second one is individual identity purpose, right? So in the IP address, that what we call it as network and host portion wise. Network and host portion. Okay, IP address is two parts. One is network part, another one is host part. You want to communicate in the network. So you are having a devices in a single segment. Within that segment, you want to communicate each other. Within the segment, you want to communicate each other. It means you are assigning IP address to every device, right? To communicate, we need a connectivity. After connection, we need to assign IP address. All are in the same segment network. But point is, their network portion in this IP address, the network portion must be same for all the devices. So then all devices will communicate each other. And host portion is different. This host portion means individual identity, separate identity. Network portion represents, okay, network portion represents all the systems are belongs to that network or not. So it will check if both systems network part is same, they will communicate each other. Okay, so that is the part of this network and host function. So for class A and class B, class C we are using. Okay, if you are using class A IP address, class A type of IP address, the first portion is network by default, remaining become host portions. First portion only network portion. For example, you take class A, you want to assign an IP address 10.0.0.0.0 For this PC, you are on to SN IP address 1.0.0.2, 1.0.2.10, 1.0.0.3, 1.1.1.2, 1.1.1.3. Okay. So it is, what is the network portion? The first portion is network portion because it's a class A. And make sure all systems are first portion is same on that. Yes, same. What about a host portion? Three portions are host portions. So in this one, it's 002. In this one, 0210. You can follow the sequence like this 002, 003, 112, 113. Like that, you can follow the sequence. Or maybe anything. Meaning is either one of the host portion or multiple host portions can be different. Host portions are individual identities. Okay. So here is also 2 is there. Here also 2. But difference is this is 0, this is 1, this is 0, this is 1. Different completely. Okay. This is again 003, 002. It should not be same to same. For example, you have another device and I put it 1.1.1.2. I cannot put like this. This is wrong. Why wrong? Same to same IP means it's a conflict. Same to same is conflict. Okay, same host should not be there. But in a host portion, at least one to many host portions can be different, no problem. One host portion or different host portions or multiple host portions can be different. Okay, but same to same should not be there. Of course, next, different networks. For example, this is 2.0.0.4. This is network portion is different. This is also we can't communicate. This will create a conflict. This will create a conflict between this one and this is different network portion. So it is not able to communicate. Okay. Understand guys, this network and host portions. Network part and host part.
Yes, sir.
Very good. Class B. Network, host. Now this time, first two are network portion only. Remaining is host portion. First two are network portion only. So we'll take some class B IP address. Okay. You can take any class B, no problem. Just unmanaging this. I can redraw again. It's compared to erasing, drawing is very easy. Or I have a circuit, so I can take a screenshot and draw on it. Now again, see, look at here. Class B, example, you take 172.16.0.1. This is the first piece, I think. It's class B. Okay, 172.16.0.2, 172.16.1.3. Okay, 172.16.0.4, 172.16.1.2, 16 dot 25 dot 26. Okay. So these are the IP addresses I assign to all these devices. Again, what is the network portion and what is the host portion? First two are network portion. It means for all these IP addresses, their network part must be same. See there, network part is 1.16. So 170.16, 170.16, 170.16, 170.16, 170.16. It means all these devices will communicate each other. And host portion definitely different. So that is 0.1, good. 0.2, good. 0.4, good. 1.3. Okay, it's not following that sequence, but still either one host portion or multiple host portions can be different. Same to same should not be there. That's the thing. Same to same should not be there. So just as an earlier example, I have a device and assign 172.16.04 also here. 04. So it is same to same. Same as this one. Means it is conflict. It should not be same to same should not be there. Okay. It can be like a maybe you are assigned 172.16 1.4. This is no problem because there is a variation in the host portion. In one part is same, but another part is different. At least somewhere there is a difference is required. Okay, maybe one host portion or maybe another host portion. Somewhere it should be unique. That's a uniquely identified. It should be uniquely identified. And network portion must be same. Next. In case for this machine, I configure 172.17.16 dot sorry 0.5 0.5 172.17.0.5. Okay, so another system 172 dot sorry 171, this time 171 16.06. Okay, so what happened? Okay, so what happened? Does it communicate? This PC can communicate with all other PCs. See the first portion 172, good. All are 172, but it is a class B. You have to check the two portions 172 plus second portion 17. But remaining devices are having 16. But you configured 17. Means this PC won't communicate to the network. Next, 171. See, first one only different network version. So no need to check the second one. It won't also communicate. So these are the devices. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 devices are there. Out of 9 devices, 2 are got a conflicts because same IP, same network and host portion also same to same. Second is 2 devices are having different network portions. In one system, second portion is different. In another system, first portion is different. Okay, first portion is different. So these two systems won't communicate each other. So these two systems cannot communicate with our network. remaining devices, because different network portion means it's different network, different logical network itself. And conflicts are generated because same network and host portion is same two system. So it is same to same. Okay. Now what is the problem? How to resolve it in case you are a network administrator and you find these 9 systems are configured like this. IP addresses you are configured manually, and you found these 5 systems are communicating, 6 systems are communicating each other, okay, and 2 systems are not communicating because of conflict. No, 5 systems, 1, 2, 3, 4, 5. 5 systems are communicating, right? So I will put a green mark on communication part. So this will communicate to each other, right? This one also will communicate. These 5 are communicating, okay? And this is not communicating. This is the red one, so not communicating, not communicating, not communicating, not. 4 are having some issues. So what you do? You check physical connectivities, then you check the IP address. Then connection is there, systems are available, but you check the IP address, you found 2 systems are having different network versions than actual network. Okay, maybe typo mistake it is. Okay, maybe typo can miss while typing IP address wrong. Not wantedly done, but it's wrong. And two out of 2 systems, same 2 systems are having same IP. Then those systems also won't communicate to our remaining systems. Then what you will do? Any idea? Just even there is right or wrong answer, guys. Tell me some different answers. No problem with any answer. If you done a mistake while writing, okay, and you found you have done mistake, the typo mistake, what you will do? This is AINESH. I put a instead of I put a E. So I realized I had typed differently, wrong. Then what I have to do? Tell me. Any answer, guys? No problem. There is no right or wrong answer for me. What I have done?
Rewrite.
Very good. Very good. So you're going to either rewrite, very good, means remove everything and start giving correctly. Okay. So we are do correction. So where the mistake is happened, either you we check the mistake and we correct the mistake. Very good. So rewrite. Rewriting is a one part. Right, very good. So we check the mistake and we correct the mistake. Very good. Same thing. What we have to do is, so I found it is 17. So what I have to do? Then I put a 16 here. Then I found this is 171. So I have to change it back to 172. And I found this is a conflict. So there is 04 and this is also 04. Make it as a 05. Before that one, Before changing it, any 05 is taken or not. Not taken. I put a 05 or 06 or 2.4. Okay. So where network portion or host portions. So if different network portion means you can't communicate. So you have to check the IP address and change the wherever the mistake you have done, you have to change it to the normal one. Any conflict is occur, so keep one IP address as same, one system same, but in another system you can change it simple. Or both you will change it, no problem at all. Okay. Yes, very good, very good. Simple things only, guys. The all, you know, most of the time what we are doing is like YouTube learning, Facebook learning. No? We just listen and then we leave it. That's why we can't remember. Analysis, thinking is very important. Yeah. The finally class C, network, network, and host. Network, and host. This is a class C. Okay. So again, for class C IP address, you have to check all three host persons. Okay. For class C, you have to check the first person only, network person. Class B, you have to check the first and second octets. First and second octets, you have to check it, network person. Class C is the first three are network persons. Last one is host person. So compulsory, you have to check the first three for a same network or not. Last one is any conflict is there or not. In a class C, only one network, one host difference is there. Okay, only one host person. I'll try with some different IP addresses. So instead of that, so one system I assign, example 190.168.1 dot, okay, 10 I assign to one system. Another system 192.168, 1 dot 200, okay. Another system 192 dot, sorry, 168 dot 2 dot 11. Another system 192 dot 168 dot, sorry, 169 dot, can use like this simple also. 16 dot, okay, 1 dot 12, okay, 190 dot 168 dot, so 1 dot 13, okay. See, I have 5 systems here. 5 systems are configured with this IP address. Then only 2 systems are communicating each other. Both systems, their network portion is same and host portion is different. First portion 192 same, 168 same, 1 is same. So these two systems will communicate each other. Next, this PC, see it is 192, good. 168, good, same. 2, it's different. So it won't communicate each other. 192, good. 16, no, it cannot communicate each other. It can't communicate with these two pieces. Okay, 190. So different from all. This is all 192. This is 190 directly. Not we don't need to check other things also. Okay. So all three network portions must be same to communicate each other in the same segment. Okay. So these are all common mistakes. People will do it even when I see in my labs. So what the people do? So I said type this type of IP address. 190 dot 168 dot something dot something. What they will type 190.168, 192.16, 172.168, 170.168. So they confuse 172, 192, 190, 16, 168. So they do this kind of mistakes. Generally, it is common type of mistakes. Okay. So re-verify when it is no communication between the devices. So why it is not communicating? Check the connectivity, physical connectivity, check the IP address, and make sure both systems are in same network, same segment. Means their IP addresses, their network portion must be same. Then only they will communicate. In case you have done a mistake, in case you have done a mistakes like this here, then change it. So this is, make it as a 1, make it as a 168, make it as a 192. And also check the host portions. So the host should not create a conflicts. Okay, these are the class A, class B, and class C network and host portions. You guys understand?
Yes, sir.
Okay.
Yes, sir.
See, here it is. These are some statements I have written here. If devices want to communicate in a network, their network portion must be same, host portion can be different. Devices are in same network can communicate each other means their network portion is same. Devices are in same network can communicate each other means their network portion is same. Okay. Next, devices are in same network means their network ID is same. Okay. So network ID or network portion must be same. And these network and host portions, it is by default network and host portions. Okay. By default, I said. The entire host portion should not be same in the same network. At least one of the host portion must be same. Means it's conflict. Entire host portion is same in the same network. It means what happened? Conflict will create it. At least one host portion. One or more host portions can be different. If you take class C, only one host portion is there. But class B and class A, 2 and 3 host portion means out of 2 or 3, one portion is different, good. 2 portions are different, good. All portions are different, good. No problem. No problem. Okay. But at least. Same thing kind of stuff. I written some examples here. Okay. So I've taken three pieces, and 2 pieces are same network, so they can communicate each other. This is different network, so we can't communicate each other. This is I've taken example from class B. Okay, so compulsory you have to check the first 2 portions. First you have to check which class of it is and what portions are network portion. All are same or not. Okay, in these 2 pieces, different network portion. These 3 pieces, same network portion. So these 3 will communicate each other, and these 2 cannot communicate it to these 3. Again, this is class C. See, there is 2 systems are having same network portion. In class, these 3 systems are having different network portions. Okay, so these 2 systems will communicate each other, and these 3 systems won't communicate it to first 2. Okay, so like that. Okay, then what is this subnet mask? When you check about your IP address, when you are checking about IP address, see, always it will show IP address and subnet mask. Then what is this subnet mask? We discussed about a network and host portions. We discussed about the network and host portions. Okay, we can understand that one. We can understand which is the network and which is the host. But how system will understand? Which is their network portion, which is the host portion. It want to communicate it to a destination system. Their network portion must be same. Same network ID they have to follow. Both network ID is same, then only they will communicate. How system will do that? How system knows? What is its network ID? So our systems use subnet mask. So you have an IP address, then subnet mask. Compulsory subnet mask. Without subnet mask, you don't understand what network you are belongs to. Okay. Using the subnet mask, it divided net IP address into network and host portions and get a network ID. Okay. System use subnet mask to divide IP address into network and host portions and get a network ID from your IP address. Okay. The by default for class A and class B, class C, the default subnet mask are 255.0.0.0, 255.255.0.0, 255.255.255.0. These are the default subnet masks. These are the default subnet masks. Okay, default subnet masks. These subnet masks will divide your IP address into network and host portions. In this subnet mask, if you write in the binary format, in that binary, the ones represents network, zeros represents host. Zeros represents host. Okay. For example, you take IP address. I think I have an IP address here. Why should I struggle? It's and simple. I can make it. Okay. Presently, this is easy. It is. This is an IP address. Okay. This is another IP. See the subnet mask. This subnet mask and IP address, if you convert into binary and do end operation, logical end operation between your IP address and subnet mask, so you will get a network ID. If both system network ID same means, so those systems will communicate each other. Both systems network ID same means they will communicate each other. Okay. See it is. First, you have to convert this number into binary and our subnet mask also. What is this logical end operation? Logical end operation means it is like both inputs are 1, output is 1. If any input is 0, output is 0 only. Okay. So it's a 1 and 1, you got 1. 0, 1, 0, 1, 1, 1, 1, 1, 1. Okay. And next 0, 1, you got 0. 1, 1, 1, 1, 1, 1, 1, 1, 1. See, this is the output. Again, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0. Okay. And again, same thing. This is also 0, 0, 0, 0, 0, 0, 1, 0, 0 again, 0, 0, also 0, 1, 0, 1, 0, 0, 0, all are zeros only. Okay, this is 0, this is 0, this is 15, this is 183. Okay, so this is the network ID. Same you have to do like this here. Then we got a network ID. Both network ID is same. So these two systems will communicate with each other. Okay. The how system will do it? So it uses subnet mask and do end operation between IP address and subnet mask and get a network ID. If both system network ID is same, they will communicate each other. The same segment. Guys, understand what is subnet mask?
Yes, sir.
Yes, sir.
Okay. If you see, this is in subnet mask, always ones are follow from left to right. Zeros are from here to here. These are 1 1 1 1 1 like that, and there is no gap in it. Okay. So these ones are stopped at this part. Okay. Meaning is this is network portion. These ones represent, these are all network bits. And ones are telling, these are all network bits. These zeros are telling, these are all host bits. Host bits. So this is network and this is host bits. Simple to say. Yeah. The ones represent network. So these ones are represent, these are all network bit, network bit, network bit, network bit, network bit, network. Up to this one is network only. This is represents host, 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 like this. Okay. So that's ones represent network bit, zeros represent host bit. Network bits, so network part is must be same. Uh, This is a network. See the network portion, class C, and this is a zero, which is starting one. This represents a network. This is we call it as a network ID. This is a network. Very first IP address in the network is network ID. In this network ID, if you convert this is the network portion, right? And this is host part. Okay. See, if you convert entire this host portion into binary, see there is no host bits, no ones in it, no ones in it. All are zeros. Means there is no host specific. All are host bits only, no host enabled bits. That's why it is called a network bit. Network ID means the host portion is completely zero. Host part is completely zero. This is called a network ID. After this, next IP address is 192.168.1.1. So if you take this one, 0 dot, so this one we call it as a first valid IP, first valid host. Okay. Like this, it followed like dot 2, dot 3, dot 4. It means there is a some port like a 0, 1, 1, 0, 1, 1 like that. So this is the first valid host we can assign to a PC. You can configure to the PC. Example, one 168, 1.0. 0. Taking, okay, it's take again. A combination of IP address and subnet mask is invalid. All the bits in the host portion of IP address are set to 0. The entire valid combination of IP address and subnet mask. By subnet mask, it is telling the entire net host portion is 0, so it cannot take it. For example, you put a 255, the last one in the network. That is also not taking. Okay. Entire host portion is set to 1. That is also won't take it. When I'm giving something 6, for example, it's accepting. Okay. So it's like that. We can assign up to 254. Can assign up to 250. This is the valid range. Up to here, we can assign to the system, not the 255. Means the entire host portion, this is a one single host portion. This entire host portion is like this. Means there is no zeros. All are ones. So all are zeros means network ID, all are ones. Host all are ones means broadcast ID. So this is a broadcast ID. In between network ID and broadcast ID, all the IP addresses, we can use it for a communication purpose. You take class B. Class C is quite easy because only one host version. Now it is class B. So in this one, this is the network portion, this is host. And this is host means this is the class B host portion, right? You take this host portion into binary. Okay. This is our host portion. See, the host portion does not have any numbers. Entire host portion is zeros, so you cannot tell it. So this is the network ID. Next, 172.16.255 means all host portion part is become 1. Okay, so this is also not a valid one. So this is a broadcast one. Broadcasting. In between 0.1, it's the first one, first valid. Okay, 1.123 up to 255, then 1.0, 1.2, like that will keep on going. Okay, so between all these devices, between all are we can able to assign. This is the last valid, this is the first valid. Between all we can assign to the devices. The very first 0.0 and 255.255, it's we can't assign to any device. Okay.
Yes, sir.
Still IPv6 is there. I thought today I will finish this IP address, then protocols, voice model. Still IP address is not complete. And that we straight away started IP address also. No problem. So understanding is very important. And I can give quick ones. Yeah. Next, if you see, I've written for a one full network from here to here, one network it is. Very first one I just told is a network ID, and very last one is called a broadcast ID. Both we can't assign to any devices. But you can start assigning from 1 to 254. Meaning is, this is a class C, one single network. In this entire class C single network, so from 0 to 255 means 256 host numbers are there, but out of that one, two we can't use it. First one and last one we can't use it. So we have to minus that, and then remaining you can use it. Like 254 we can use it. So that's why in a class C, one single network like this from the single network. Okay, in this single network, we can assign IP addresses up to 254 device in single class C. Okay, in a single, any range you can take it. In a class C, any range you can take it. Take 192, 193, 194, up to 223. Okay, anything you can take it. But in one single network, you will get a 254 number of IP addresses, valid IP addresses to assign. Means up to 254 devices you can connect in a single network. In single network, up to 254 we can connect using class C. Again, class B. Again, class B. In a class B also same. I've taken 172.16.0.02, 170.255.255. So this entire range is 65,536. Two host portions, right? Two host portions means 8 bits. 16. 2 to the power of 16 minus 2. 65,536 minus 2 means first one and last one we can't assign to any device. It means 65,534 devices we can connect in one single class B network. In class A, it's of 3 host portions, 2 to the power of 24 minus 2, 16 million triple seven 214 devices we can connect in a single network. Okay. For example, in your organization, you have a 50 computers. So you have to assign an IP address. So you have to plan which class of IP address, which range in that one. So class is enough because 50 means class is enough. Then another extra devices are added. Now it is totally 100. No problem. Class C still support 100 IP address in the same network, same logical network. 200 still no problem. 250 no problem. Okay. 300. So in one single net, 300 there is no. Then you have to go for class B type of network. 300 devices. You plan for class B only, not a class C. Just class B is enough. 300, 400, 500, 1000, 5000. 50,000, 65,000. Still we can use it, a class B only. 70,000, now we can't use. So go to the class A. Okay. Depends upon your network size. You will choose which IP address from which class you will take it. Depends upon the size of the network. This part already I told. One line it is there that is called a subnetting in between. What is this subnetting? We can divide this big network into small network parts, small subnets to save the lot of IP addresses. Mainly public IP addresses are very costly. Private IP addresses we can use within the private IP address range only. We can use. But public, like my organization required a 20, 10 public IP address only, or 20 public IP addresses only. But if you take class C is getting 254 IP addresses. So if you got a class C type of IP address, 254 is very difficult. Then this, what it is, this subnet means they divide one network into multiple pieces based on my requirement. So then I want 10, so I will get 14 IP addresses. Round figure. Okay. Okay. What I will do. Okay. So when you're typing a IP address, you must specify the subnet mask. So you give an IP address and subnet mask. Or your or instead of writing a subnet mask like this, in some places, some systems, some places, you should give as a prefix like this. Okay, instead of IP address, sorry, instead of subnet mask, you can give in the slash notation. That would be called as slash notation, which represents subnet mask. It is also called as prefix or CIDR method. Prefix, CIDR method or slash notation is same here in networking. So what it is? So this is the slash notation representation of subnet mask. Okay. So then how to write this slash notation? You take a subnet mask, convert into binary, count number of ones, network bits, that is your slash notation. You take 255.0.0.0, then there is 8 ones inside, then slash 8. 255.255.0.0. 16 ones are there, it means slash 16. 255.255.255.0 means 124 zeros are there. You see, this is 240. 255, 255, 240. It's just only 20 ones are there inside. Okay. So like this, these slash notations or prefix CIDR method represent your subnet mask. Guys, by default, we use default subnet mask generally, default subnet mask only we use it. So that type of IP or network we call it as a classful network. That network we call it as a classful default subnet mask. But you change the subnet mask for subnetting purposes to change your network size purpose. Okay, that is like customized subnet mask. If you are using different subnet mask than default one for your network, means classless network. Okay, this is about your IP address, guys. There's few more things like what is private IP and NAT and PAT, how to assign an IP address. Then only we can go to the, of course, IP address is also there. So what I'm going to do is just I'll give you a small explanation about IPv6. Then we'll see the IPv4 and IPv6 differences. Then we'll close today. Okay. IPv4 and IPv6. IPv6 is 128-bit. Okay. IPv6 is 128-bit. In binary. So 2 to the power of 128. So 3.4 into 10 to the power of 38. That much big IP address you are getting. Billions of IP addresses. Like a decillion. It's a very huge size of the IP address compared to IPv4. Okay. IPv6 represented in hexadecimal format. Hexadecimal format. Hexa numbers are represented with a 4-bit binary format. One single hexa is equivalent to 4-bit binary and direct translations. Okay. This one hexa is 4-bit. So totally 32 hexa numbers are there in one single. Thirty-two hexa numbers are there. These 32 hexa numbers are divided into 8 blocks. Divided into 8 blocks. Each block 8 blocks contains 4 hexa numbers divided by column like this. Divided by column. Okay. So we have 8 blocks. Each block contains 4 hexa numbers. Okay, hexadecimal and divided by separated by column. This is how IPv6 is look like. Guys are okay? In IPv4, we have taken entire range. We have taken entire range of IPv4 and divided into 5 classes. Okay. And in that one, there is a multicast address and unicast address. Again, we didn't discuss that one. Private IP address is there. Okay. Public IP address is there. Okay. Separately, we have written. But in IPv6, it's not divide entire IPv6 into classes. There is a certain ranges it is specified. There is a ranges are specified. Example, public communication purpose for internet public communication purpose. So they give it a range is 2000 like this. /3. The range is /3 for public range. 2 means in a binary 0010, another 0, another 0. That hexagon. Okay. This is constant. Meaning is it's like 200, right? So what is the last one? Like this. Okay. So what happened here? This is 3. F, F, F means this is the final range. This starting one and this is the ending one of the final range. This is like global unicast. Global unicast means public IP address. Global unicast, the public IP. Private IP. Within the private, you can communicate. Within the private, you can communicate. Okay. Link local, FE80. System self-generated IP address. System self-generated IP address. FE80. So even you check your IP address, okay, in IP address, okay, IPv4 must be assigned. IPv6 is not required because this is a link local IP address. This is system generated IPv6 address based on your MAC address. Within the segment you can communicate. Within the segment you can communicate. Right. This is a segment. Within this segment you can communicate using this link local IP address. Okay. But outside of segment, with like a routing part is not there in private and public. Okay. Multicast, anycast, private, link local, global unicast. These are the different ranges for public, private, same segment network communication, multicasting purpose also. And we discussed about a link loopback and local host. For IPv4, it is 127.0.0.1. For IPv6, it's colon 1. Okay. In IPv4, 0.0.0.0 is there now. In IPv6, it's a colon only. Okay. So these are the basic differences, guys. In IPv6, you don't have subnet mask. In IPv4, we have a subnet mask, which is used to divide IPv4 and IPv6 addresses. I think somewhere I've written about it. Wait, hmm? I will search. It is. Uh, yeah. Okay. IPv6 is not divided into classes. Okay. IPv6 is not divided into classes. Global unicast represent public IPv6 address and private IP means use not what is 1 minute, not routable in a public but we can use in private. Link local IPv6 address, it's FE80. When we use IP address FE80, it is non-routable in private as well as a public. System self-generated IP address based on the MAC address. You can communicate within the segment. Multicasting IP address is for multicasting purpose. And any cast means generally IPv4 will do broadcast, IPv6 do IPv6 do anycast. IPv4 broadcast, IPv6 do anycast. Broadcast means send packet to everyone in the network. Unicast, sorry, broadcast means send packet to everyone in the network. Anycast means if both systems means the destination, the connected devices, exactly say the connected devices are enabled with IPv6, then only it will send. For example, you take this properties. So their IPv6 is check mark is there. Means that type of devices. Either it is IPv4, IPv6 or only IPv6 device. So it will able to, it will send like a broadcast type, any cast thing, it will do it. A device with only IPv4, it won't send, our system won't send to them. Okay. And there is no subnet mask. We don't use any subnet mask, but we do prefix or slash notation here. Slash 64 means the first 64 bits means first four blocks are network portion. Remaining are host portions. Okay, remaining are host portions. The first four blocks are first 64 bits are network portion. Remaining is host portion. So network and host portions will be divided with a simple slash notation. There is no subnet mask, subnetting concept, subnetting calculations are not required. Okay. So this is about your IPv6 also. IPv4 and IPv6, the difference is IPv4 is 32-bit, IPv6 is 128-bit. Okay. IPv4 represented in decimal format, IPv6 is represented in hexadecimal format. IPv4 4.3 billions of IP addresses, IPv6 is 3.4 into 10 to the power of 38, whereas we can say it's a billions of IP address. Okay, IPv4 is divided into 32-bit. It is divided into four parts separated by dot. Each part we call it as an octet. So then we got a four octets in the IPv4, whereas IPv6 contains 32 represented in hexadecimal format. We have totally 32 hexadecimal numbers separated by 8 blocks. Each block is separated by colon. So each block contains 4 hexadecimal numbers. And IPv6 is very bigger and it is secure. Even it is a bigger but faster. Why? Because of hexa numbers easily convert into binaries. So it is very quite easy of converting into the binary as compared to decimal numbers conversion. Even it is a bigger one. Okay. And IPv4, the total range is divided into classes. In IPv6, is not divided entire range into classes. There is a specific ranges are for a specific purpose, like global unicast, link local, private, multicast, and unicast type of kind of stuff. In IPv4, we use subnet mask, and IPv6, we don't use subnet mask, we use prefix to represent network and host versions. Okay. Not every country is implemented IPv6, guys. So in the globally, we are using IPv4 only, but some countries, some private organizations, and some countries, mainly Geo, you take Geo, IPv6, they're using it. Okay, certain countries, they are using IPv6, purely IPv6, like Japan, Germany type of countries, using IPv6. Bigger countries like India, America, like that countries, that are not using this IPv6 in a public communication. It depends upon the countries or organizations use IPv6 or not. Okay, that's the point. Okay, guys, understand the difference between IPv4 and IPv6?
Yes, sir.
Very good. Okay, that's it.